This is Quick Clip 2.11, Properties of Matter. And in this lesson, we discuss both physical properties and chemical properties. When considering chemical properties, we can think of it as the different ways a substance can react or change to make new substances. For instance, whether or not something is flammable and can burn, or if the material will rust or oxidize, whether or not the substance will decompose, or if the material is poisonous or toxic. In each of these cases, there is a chemical reaction and a new substance is created. Here is a reminder of how chemical reactions occur. So in a chemical reaction, bonds are broken of a molecule, and the individual atoms will reform as a product and as a completely different molecule. So here you see a depiction of two different molecules. The atoms will break apart and then reassemble on the other side and form a completely new substance. So that would be how a chemical reaction occurs and how new substances occur. And this happens with the chemical properties of that substance. Next, we have physical properties. And physical properties have more to do with the appearance or the function of that material. And no new substances are formed. So oftentimes we think of just merely the appearance of a material in terms of its color or even possibly its odor. Also, when we think about the function of a material, this would include at what temperature or what point will that substance begin to boil, or at what temperature point will that substance melt or freeze. These are all examples of physical properties. Another example of physical properties that have to do with the function of a material has to do with its malleability or its ability to change shape, whether it can bend or be pounded flat. Also solubility, whether or not it can dissolve in water. Also whether it's conductive or it can let electricity pass through. So again, physical properties have to do with the occasions when no new substances are created. For instance, if you were to mix salt with water, that would be a solubility, but there's no chemical change there. So this depiction shows two molecules that are being combined together, but there's no chemical change. And so it would be a physical change, not a chemical change. So the molecules aren't going to break apart, and what we have on the left remains to be the same on the right. And this would be an example of like salt being dissolved in water. The water and the salt still remain intact, and they do not go through any sort of change. Another popular example of physical change would be the different states of matter. So we have ice, and we have water, and we have water vapor. In each one of these cases, the appearance may change, right? The state of matter changes, but the molecules themselves remain the same. So ice is still H2O, while water, again, is H2O. And when it evaporates into the air, the molecule remains intact, and it is still H2O. So here's another example. Let's say we have a piece of metal as a solid, right? And so all the atoms are arranged in that order like that, right? And you can see that it's all together in a solid. When we heat it to melt it down, then the molecules, or I'm sorry, the atoms are still the atoms. Nothing has changed. The arrangement has changed. So it has just changed from a solid to a liquid. So it's changed its state, but it has not changed the substance at all. Nothing new has been created.